Hello, everyone. Welcome back to the LiveCTF stream. We just now closed the first challenge that has been running for the past 4 hours. So what happens now is that the next challenge has just opened. But before we get to that, we will talk a little bit about the challenge we just had, what it was about, look a little bit at the solutions, some statistics around the number of solves and so on. And so this challenge was created by Jordan. So I'm gonna throw it over to him to kind of lead this summary of the challenge that we just had.
Great. Thanks, Carl. So yeah, this challenge was called What a Maze Meant, because I'm a dad and I like dad puns. Specifically, it was a reverse engineering challenge. So it was less of a pwnable and more of an RE challenge, which is something we promised people we would do more of this time. Let's talk about like the numbers and how many submitted. So we had 40 teams with successful solutions in that 4-hour window. And so the first and top scoring team was MHackeroni. And so they're going to get the maximum of 50, and everyone else's points will kind of go down from there. Now is actually a good time to mention, if you had a really clever solution that you think you'd like us to show off, tell us in chat, tell us in YouTube chat or in Discord, and we'll highlight it and we'll review it, and we'll either compliment you or mock you, depending on what we think. No, we won't mock you. It's like CTF exploits, especially speed runs, are really hard when you're trying to like balance your, like, you're not trying to write pretty solutions. You're trying to write solutions that work, right? So,
I think we will see some examples of like this varying quality of code. Yeah.
The dirty,
talking about going fast too. I was just scrolling through solutions. Maple Bacon was 3 seconds off of max points.
Were they really? So they just missed outside the window. Yeah, that's more like now. But here's the thing: did they use like the Docker that was very similar to ours, or did they do their own custom Docker? Because like it could have literally been.
That could have been the difference.
Well, submission time. Actually, I take that back. It's not, because we start the clock from the submission time. So if your build is slow, it doesn't necessarily penalize you as long as your submission time like was in early. And that way too, because it's a bunch of different runners, like we don't want weird network performance or weird like ordering of the queuing of how things are being built or run to impact the team score. So yeah, it's so they were just close on like the original submission time. But like being off by 3 seconds of max points means they only missed like 1 point, right? So it's a tiny difference, like maybe a tiebreaker.
It's a tiny difference, but it could be a tiebreaker. Yeah.
Yeah. So although I think that's the nice thing about like a lot of the self-balancing points is that it sort of like includes a lot of automatic tie breaking, because there's very few challenges that are the exact same number of points. So unless you and another team have the exact same solutions, over every challenge, then you're liable to have a different score. So, all right, let's talk about what amazement is. So first, like this is the source code to the binary here. At a high level, it's just a little maze solving challenge. You have to walk through the maze, you have to get out and get out alive. Now, the only slightly tricky part about that is that at the very end of the maze, if we go through the source code real quick, you'll see there is there's where we're walking through the maze. And here's the slightly interesting part of the challenge, which is you've got to get very lucky, right? You've got to be able to, like, when you walk out, you've got a 1 in 1,213 chance of making it out alive. Most of the time, you're just going to die. Also, if anyone hasn't seen the Dungeons and Dragons movie, it's really good. You should go see it. This is the High Sun Games is kind of what inspired this particular challenge. And so the Displacer Beast was like the one of the monsters in the maze from the movie. So that's what ends up killing you. You can tell during debugging, I had easy mode where I could just dump out the number of times random was called. So like the intended solution here is you've got to actually know how many times rand is called, and you have to be able to know what the seed is. And I leak back the random seed indirectly by giving you a bunch of like random stats in every room you go in. So like actually, if we just run this one real quick, and I'm running at an M1 max, so I'm running a slightly different version, but the executable is the same.
Maybe you could increase the font size of that terminal just a little bit.
Yeah, we'll make that a little bit bigger. Perfect.
Yeah.
So this is like when you first run it, you've got like this reticulating splines. It's kind of like old joke of like a load screen text. But what's interesting is like it actually matters, because that like spinner does two things. There's like this little like spinner that happens, and one is like an intentional pause in the service, so you can't spam or brute force the service because you have to wait just a few seconds like for that to run through. It's not like painful enough that it's actually going to block you. And you have 2 minutes to solve, like, so you get a lot of tries potentially, but it just slows you down enough that it like has a tiny bit of a delay. The other thing it does is every actual time that that spins, if you actually look back at the source code, all of the calls to rand go through this rand range, almost all of them anyway, go through this function. And this function has, you can see there's the timeout, and that's also what is putting, it's printing out that little spinner character. So it just prints this like different characters. And so you can count how many times RAM was called, because it's seeded based on the time of when you connect. And I mean, you also could ignore all this and just get lucky. Like if your time sync is very close and you have the same libc, you may not actually even have to do that. So there was like the sort of careful for sure way. So like my solution actually would brute force the rand based on a range of values and verify it by tracking it. But you could assume you know the seed, but then the problem, actually no, you still have to know the total number of rands, because the problem is, again, when you walk through the maze. So like actually if we do this, also by the way, there's a spell you can cast if we look at the source code. Oh, and if you're curious, looking over at the decompilation, right? Full symbols were included. Like this was not meant to be like you have to figure out what this stuff, like there's no, all of the functions are named appropriately. You can create all the right structures and you can see what it's doing. So like you should have a pretty good idea, even just getting the binary of kind of what it does. But you'll see there's one little, where is it going? Yeah, here's our switch statement for like checking your input. And we noticed that there's this, there's a couple, so the normal east, south, northwest instructions and a quit. But we've also got this A, which is Arcane Eye. So we like get a mapping spell. It's sort of like the in-world lore, right, of D&D style. But if we just do that, it actually shows us the maze, which was, again, kind of more just for testing. Obviously, your solution script, you don't want to waste like the cycles doing it. So we actually make the font a little smaller just so I can fit the whole maze on the screen. Oops, wrong hotkey. Wrong hotkey again. There's the right hotkey. All right, so now, so you can see the character kind of walks through the maze. So again, if we look at the room description though, right, like the actual room randomness comes from those rand calls. And so you could validate like the state of the random seed. And my first solution, I was going to like pull out all the bits of entropy for like, because one call to rand generates a bunch of bits, and then it extracts out and uses that to determine, is it a large room or a small room? What's on the wall? What's on, like, how many flowers in the vase? What's the room design style? But really, like my final one, all I did was I just looked at the number of stars, because I think there's about 14 bits of entropy in the star calculation. So if we look at like how the random description is actually made, yeah, stars gets actually it's whatever remains left over. So it strips off 14 bits of entropy, which we use for all of the other ones. I'm looking at, I think I actually, yeah. So you could have used any of these or all of these, or as much as you needed, but you just need to be able to like be reliable enough to know you've got the random seed, and then you didn't know how many times random is called. Again, you could have actually brute forced like any of those without actually tracking it, but because you get those like spinning characters, and because every time you walk into a room there's one called a random, you can just kind of count them as you go through it. So I think that's probably the most tedious, like knowing what to do is probably something teams looked at this and went like in the first 5 minutes, like they had a general idea of what to do, but then getting the counts right, getting the random seed and generating, that's probably the piece that you kind of had to get right. But once you make it out alive, and if I actually make it all the way through the maze now, I'll almost certainly die. But again, if you have been tracking the random, I don't even think I want to walk the whole maze. It takes a little bit of time. Actually, in testing, I played with different maze sizes too, just to figure out what was the right size. And this was just like large enough that you could totally manually solve it, but it was tedious enough that you wouldn't want to. So yeah, that's the challenge. But let's talk about the solutions. So let's see here. Let's pull up. I think MHackeroni had the very first one. Actually, if we look at our, yeah, if we look here, so we can see this is like the total list of complete solves, the team name, and the timestamp. And so we can see where they like came in at. So we had several. They were at like the max point value, right? because again, within 6 minutes, you're going to get the same value. So
yeah, so we had 3 solves there, right? The Hackeroni, Katsabin, and Blue Water all within the first few minutes. Yeah.
Yep, because they were all 3 minutes apart. In fact, actually, yeah, these two, Katsabin and Blue Water, were seconds apart there. And then these are the folks that start to lose a little bit of point. But again, like they're all still so close. It's only a couple of, in fact, yeah, we could probably bin these and get a better idea of like how many points off they are, but not a whole lot. But then, like, the further down you get, the smaller your take will be for that particular challenge. All right, so let's actually go. Yeah,
I actually think it's interesting to see there, if you look at the bottom of the list, that we had solves coming in like up to the very end. That's like the last one that says like 3 minutes before the deadline.
And good for them too, right? Because that's still it's still going to be a good chunk of like 15, 17 points or so. I don't have to figure out the exact amount that they got, but like that's still a decent chunk of change.
Yep.
So yeah, you should not give up if you have a chance of solving it at all. So good work, team Answer. It's like answer backwards or answer with a dyslexia. So let's look at MHackeroni's. Oh, and just a quick note too. I want to make sure we reiterate this. The main website that has all the rules and information stuff on it, we weren't trying to like bury it, but at the bottom there is the note that like we want to make it clear that we are going to be talking about team solutions. We're going to be showing them off, and so don't put your super secret Turing framework magic in here that you don't want other teams to know about unless you're okay with it being shared. Because not only are we going to talk about them now, but just also in fairness, at the very end, we're going to upload everything so you can inspect everybody's solutions and see what things people did differently. So they're all going to be Apache 2 for their codes. All right, so let's go back to MHackeroni. And they had like there was like different styles. So we had some people who uploaded just a Docker file and one Python file. Some people uploaded more. So like again in this particular one, and like this maze challenge where you have to like track the random or leak the random and like match the random seed. I feel like is one of those like quintessential like CTF design ideas, because like one of our goal with LiveCTF is to try to make all of our things like the sort of distilled essence of like a simple concept that happens a lot, of something you see a bunch. So that's why like teams probably like knew exactly what they had to do. Again, very, very quickly, they can see it, and then they just got to like get it right and get through bugs and like get it working. Because this is kind of like a common, right? It's a common thing of like trying to match the seed to for whatever reason to like get your magic value.
And I think, I mean, generally with the design of the challenges, like we have them in 4-hour slots, but without kind of like downplaying, people who submitted a solution like 3 minutes before the end, but they're not intended to take a full 4 hours to solve. That's not the intention when we build these. They're supposed to be quicker than that.
Yeah, if we had one that like in playtesting took more than 1 or 2 hours, it was too hard. Like even though the better teams are probably better than some of our playtesters, right? Because there's a lot of great people. But just like in general, we wanted to be like sure that we were scoping them around the 1 hour mark. So like honestly, 40 minutes I think or so for the first. Was it even faster than that for the first?
It was 25 minutes, which
25 was way off. Oh yeah, exactly. That's perfect. Like I'm totally fine with a 25-minute solve. That's fantastic. So yeah, very well done. Yeah, like that's perfect. If they solve it in like 5 minutes, maybe that was a little too easy. But that's okay. Hey, if they're good, maybe chat. I want to know how many people had ChatGPT help them write their solutions. We'll see if teams mess up. I mean, admittedly, I actually had ChatGPT write my maze generation algorithm. So this actual algorithm here, I was lazy and I asked ChatGPT to write them. It was a little busted. I had to fix it a little bit, but it mostly worked, which was nice. Yeah, one of the things that we saw different teams do is some teams took the libc that came from the handout and included that in their solution script, and some people just relied on it being generated by the solve infrastructure, like it's already kind of provided inside the VM. And it turned out like that was a fine choice because it did work, but I totally get why some teams were a little more like, yeah, we're going to use the exact one that was given and include it. So you can see that, yeah, just using C types to directly load that, and it works, kind of exactly the way you'd expect. You can call srand, you can give it the right value. This is true, like speed mode. I feel like right here, right? The shortest variable names possible, And actually, I wonder how much of this was boilerplate. Like this feels like something that we'll have to go look at their solutions in the future.
This feels like something they prepared beforehand. This like reminds me a little bit about I used to do competitive programming as well, and people had these like super cursed defines for like macros for for loops and all of that stuff, and it kind of reminds me of that.
Yeah, and I expect that's it for better or worse. That's kind of what we're driving people towards a little bit with LiveCTF, and I've heard some like traditional CTF people say like, oh, it's not the same. And I totally agree. Like there are people who are going to be very good at LiveCTF that are not as good at the harder, more in-depth stuff. It's just a different skill set. And I think it's cool to like show off a slightly different thing. Even if like, for example, I might only be mediocre at LiveCTF, because they're like the fastest people are very, very fast, but it's super fun to see how quickly they can do it. So yeah, even this feels like a little bit of like just boilerplate, right? So they're getting their config, whether they're going to do remote or local. And yeah, this is another one where having like a debugging interface where you can verify your assumptions as you're testing it locally was really helpful. Like you could actually check that your random states were aligned, where you're tracking the randoms. And you can see, yep, they're initializing their random immediately after making the connection if they were doing it remotely. And so in my testing, this is actually very reliable. Like you actually could get really consistent. I built something a little more rugged because I had the luxury of time where I actually brute force just in case there was a little bit of time off here. But you can also just, put your stuff in a while loop. All right. So they're just going to look for, they actually did turn on the arcane eye mode, which is interesting. I wonder if they're actually pulling the values out from that. Yeah, so they're actually reading out the maze, the full maze from here. That's cool. So like my solution, for example, just did like the wall walking where I didn't actually care about the visible maze itself. I literally just looked at the north, south, east, west directions you could go, and then followed the wall until I got the exit. So this is cool that they're actually pulling out the maze state. And yeah, mapping, they know the positions of the player, they know the positions of the exit, and then they're trying to avoid backtracking with the visited list, looks like. And then depth first search. Okay, so they're going to totally solve the maze initially. Yeah, that's a cool trade-off. They're going to solve it right away. So if you're trying to like do this very, very quickly, ironically, even just having that map turned on does slow down your connection a little bit because you have to walk a lot of rooms, maybe several hundred steps to make it through the maze. Depending on the maze, I saw anywhere from like 300-400 up to closer to 1,000, I think, depending on the route that you could have to take, if I'm remembering correctly. So yeah, you can see they're actually doing their solve kind of locally first, get the path through the maze, and then they're just going to convert their path into the coordinate directions. Yeah, this is to do this in 25 minutes. This is really impressive.
We opened this up. We saw the solve and we opened it up immediately, and we're like, they had to have this ready. And I looked through and I'm like, no, they wrote like 100 solid lines of like maze solving.
Yeah.
And interaction here.
Yeah.
And then the next one we look at it, it's the same stuff, but the variable names are one letter instead of full words.
Oh, is that the next most solution after MHackeroni?
Yeah,
so the
it's just
one?
the same code, but it looks like it was run through a minimizer.
Yeah, so here's Catsbin's solution. Oh yeah, that's much. So they've got that is truly minimal stuff. And again, same thing, depth first search. So yeah, it does make, and this is where I'm not surprised that like a lot of the fastest teams, they may even have had a depth first search like from previous challenges. They just popped in, or maybe asked OpenAI for it real quick. I'm not sure.
I could have some of that ICPC competitive programming experience as well, where people can like spit this out in 15 seconds.
Just off the top of their head. Yeah, that's just muscle memory at that point. Yeah, I would believe any of those. So yeah, very, very similar. And again, that's cool. That's where like it took me a lot longer to solve it when I was doing it. So actually, I'm curious to see now, do people see that is the one nice advantage of when they're computing the path in advance, just the length of the list times 2 gives you the total number of RAND calls, right? So actually, let me go back to MHackeroni. And just again, for context, this was Catsbin here with they're certainly more concise. And so they're going to walk it, and then, yeah, so then they're just going to literally, this is very, very similar. Basically, just keep walking until you, yeah, walk back and forth on your solve path until the random is valid, and then take your exit. So yeah, very good. And that's all you need to do is send submitter, and you're done. Perfect. All right. And let's see. Is it very similar? Yeah, same kind of thing. Right. So they're doing the same kind of random walk. Though I think there's actually. Oh, that's clever. Hold on. I just did notice that.
They don't even move. They just.
No, yeah, exactly. Right. So you notice they literally gave it a 0. I did intentionally do this. I think I forgot about it when I wrote my solve, but you can literally give it an invalid input and it will generate, even though your position doesn't change, just give it any input. Yeah, that's far more efficient. I was actually doing backwards and forwards and doing 2 rand calls for mine. But I think I did change it towards the end because I wanted to make it a little bit easier to like spam random, right? So you can just hit, in fact, any input. Although you have to be careful. If you give it 2 letters, it will actually, I think, read a character, so it'll do it twice. But yeah, and then you can just keep doing it until your random works. Very cool. All right, have we had any? I'm curious if any teams have specifically highlighted any interesting things that they've done, or.
I haven't seen any messages in neither the YouTube chat or in the Discord from the DEF CON CTF. So did we look at the next, like the third?
So I'm going to pull up. So third place is Blue Water. I'm actually going to skip down to Maple Bacon, which is our first off the out of the bubble or whatever, I guess, because you notice they actually were the first team that actually tracked the validated the random seed, right? So this is them pulling out the stats for the random seeds. So this is the sort of more precise or correct. And if for example the the clocks have been skewed or there's any other problem with your SRAND, you'd be able to validate it with if you did it this way. And so they actually pull out the description and then match out with a regex all the different values, and then so they're actually calculating. Oh, that's very cool. So this literally is going to turn the it's going to turn the description back into the rand call. So literally, like, this is like undoing, like literally sort of decompiling what the actual like function when it generated random. Where was the random description? So the random description function does essentially the same thing, right? It has these arrays of styles, and then it actually uses the random call to like to split out all of the different bits of each of those, and so it's essentially just undoing that. So that's actually really, really cool. That actually, I was curious how many people would actually do that. And then again, you can see they've got a brute and offset here where they're able to handle like if there was any kind of drifter stuff. So this is a little bit more robust. It turned out it wasn't necessary, right, in this particular case, but I can totally see why they sort of like, made that choice when they're writing it, like, and didn't want to assume, because if they're, if you're wrong and you've got to go then build this and afterwards, it could have slowed down your solution. So that's kind of cool. And let's see what depth first search. I think everyone's essentially implemented the same thing. Although they're doing, so they're also, I'm curious if anybody else solved it blind or if they all just pull out the maze and then implement the proper solution to pull that. But
I really want to see the solution that did like flood fill.
Like, just
something overcomplicated.
Like, really, it's completely unnecessary, and yet, we could probably actually just grab through the source and see if anybody. Oh wow, this is okay. This has got to be ChatGPT that generated this one from Parliament of Ducks. Let's check this out, because like, come on, they added documentation.
100. There's no way.
Right? Right?
Unless they
Oh,
copied
it's
this from
amazing.
GitHub somewhere.
Okay, hold on.
No,
Yeah,
that's
yeah.
the description. Yeah, they just wrote the. That's
Let's see.
great.
I want to see if this is like actually like boilerplate somewhere. Maze solver in Python.
Nope.
Oh, let's go.
Yeah,
There it
totally.
is. That's awesome. Oh, that's so funny. Like the yeah, that's really cool. So that makes sense then. So they actually found that example there and then just changed the symbols probably. So let's see what, did the original one. Yeah, okay. So they just had to change their symbols to match what I had done on mine. I'm glad I didn't accidentally match the exact like ASCII characters of this random like script, because if I had, that would have been like a little too easy. Yeah, so found that and then basically applied the same thing. They also pull it out and then they're going to solve it. Yep, they get the solution and then just walk through the solution. This is interesting. How? Okay, yes, yeah, and so they do the same thing, right? So they've hard-coded the maze generation random calls, and then they count how many steps their solution is, and then they just increment the counter until they find out how many times they need to do it. They do the. I do think it's funny that I totally forgot the in my solution. Everybody else's public solutions are much smarter about just changing the random seed in the last room, but. And then they're even being more robust about making sure they're flag matched, and then they submit it. Very nice. Oh, that's cool. Okay, so I think we don't have a confirmed case of AI assistance, but we definitely have some found solutions. But yeah, I think we'll be kind of keeping an eye out, and we'll see if we see any other fun solutions throughout the event. And like I said, for future ones, we really are hoping teams like let us know if they have something in particularly that they thought was cool, or they thought they might have done differently than others. So
yeah,
I do hold on. I did notice somebody's who is this? This is Orga Kraut has a Arch, Railroad, Stack, NX, and Pi settings in their like solve template. So I think people have like several like helper scripts now that they just feed into binary and it starts their payload for them, which is interesting.
Yeah, it's really cool to see these things, right? And is there anything more we want to say about the challenge we just had, or like solutions or statistics?
So like I said, I think we had 40 solves on this particular challenge. I think it's also worth mentioning that we had 256 teams, nice power of 2, that have solved the test challenge. So there's at least 256 teams that like have the infrastructure to submit a working solution. So that's the sort of ceiling of like total people that we could expect to solve, future challenges kind of going forward if they can get past the whatever is kind of in the challenge.
Yeah, no, that's really cool. So that's then kind of the challenge that we just had, but we also have a challenge going on right now. It's called Benchmark. Josh, it's written by you.
Yeah.
Is there anything we want to say? Yeah.
I'm obviously not going to give any hints besides hack harder. So we're what, 32 minutes in? Yeah.
Do we have solves
minutes
yet?
in, no solves.
Okay, so you are successfully a harder challenge than mine.
Well,
but
we'll see if it's too hard. I don't think it is. I think it's right in the middle. But we'll see.
Can I just throw out how much I like you can't even see the other descriptions that are being logged in. I'll have to log this one into one of the other teams, because it's really fun doing the little art for each one of them on the Nautilus Institute scoreboard. It's great.
No, that was the last minute edition. It's really funny.
Yeah, I like it. I especially like that the practice challenge is someone drawing a house with crayons.
Fuzzle did that one. So I did all of I made up all the other images for the later challenges, but I forgot to do one for the test, and so Fuzzle did that. Just don't look too closely at the hand, because the thumb is, yeah, thumbs don't bend that way, not normally. But it's even part of the charm of AI generated images.
Awesome. Well, with that, then I think we're gonna wrap this stream up. We will be back in about 3.5 hours for the wrap up of this challenge benchmark and looking at solutions and so on for that challenge.
Hopefully.
And hopefully. And releasing the next challenge. So yeah, in the meantime, have fun with the CTF, and yeah, that's it. Anything else, Jordan, Josh?
Nothing for me. Thanks, everybody.
No, nothing.
Good. Well, see you later. Bye.